Hello, my name is Virgil Cox. I'm Dean of Engineering and Industrial Technologies at Gaston College. The goal of this video is to ensure that you matriculate in an appropriate engineering field program that will ultimately lead you to your occupational goals. That sounds like it ought to be pretty trivial. Unfortunately, the English language has made sure that there's ambiguity everywhere. And in the process of using the word engineer, in the general public, it is totally legal to claim the title engineer by driving a railroad train. It is also equally legal with a PhD in electrical engineering to claim the same title by doing research that keeps the rover moving on Mars. We know that those are two very different occupations and that they definitely require a great deal of different kinds of education. They have one thing in common. They sit sort of at opposite ends of a spectrum of engineering field occupations. In that spectrum, there are hundreds of job titles titled engineer. Something that those of us who did our education in order to be able to earn a living ultimately figured out was that there are actually only two kinds of post-secondary education: occupationally oriented and everything else. Occupationally oriented education, which is on focus, is going to prepare you to work in that particular occupation. So as we look at that spectrum of engineering field occupations, the question becomes, what is the real core differences between what a railroad engineer has to know and be able to do and what a research engineer has to know and be able to do? Well, it turns out that there are actually two major characteristics of the education which must show up in those curricula in order for them to be on focus. One of those characteristics is craft skill. At the railroad engineer end of that spectrum, craft skill, that is the proficiency at accomplishing specific tasks, is absolutely paramount. If you can't wire a house at the same rate of speed as the other electricians, you're going to get fired. If you can't put out blueprints at the same rate of speed as the other draftspersons, you're history. Well, what about the other end of the spectrum? Well, at this end of the spectrum, we end up hiring paraplegics, quadriplegics, and we do not hire them for their craft skill. And if you look across the spectrum, you realize that the craft skill requirement goes from absolutely paramount all the way to totally insignificant, and everywhere in between. An engineering field education must take that into account. Therefore, how do you become proficient at a craft skill? Well, not by watching videos, by doing it. You're going to have a high lab time and relatively low seat time. You have things you have to learn in order to be able to communicate with your fellow workers, but you will spend a great deal of time creating the proficiency at the occupation. The other characteristic has to do with the sophistication of the models that you use to answer the question, how much? Now, if you're going to become a psychiatrist, I would change a couple of words in that sentence. The sophistication of the models that you use to answer questions in psychiatry. In the world of engineering, the toughest questions turn out to be how much questions. And we cannot answer those questions by saying, oh, lots. Nah, just a little bit. We have to have numbers. But that means we have to know the meaning of the numbers. we have to be able to calculate those numbers, and that means we need to deal with the math that's behind those numbers. At the railroad engineer end of the occupational spectrum, it turns out that it's occupationally oriented math, and the model is provided. Let me give you a quick example of what I mean by that. If you wish to become a machinist, you'd better know some right triangle trigonometry. So I'm going to send you to a mathematician who's going to teach you enough algebra and trig to be able to manipulate those mathematical variables proficiently. When you come back to the machine shop, I'm going to be talking about real-world values. I will connect one of those real-world values to a mathematical variable. But you already know how to change that into a different mathematical variable, which I will connect to a different real-world value. You will begin to start thinking about the relationship between these real-world values through that mathematical model. I will not spend 1 second of your time teaching you spherical trigonometry when all you need is plain trig. Now let's look at the other end of the spectrum. Here we put a man on the moon. That required answering hundreds of thousands of how much questions that hadn't been asked in 5 billion years or more, and required the creation of thousands of new mathematical models, many of which required the use of very sophisticated mathematics. If you put that concept on the occupational spectrum, you realize that this end is job-appropriate math, model provided, and this end is potentially extremely sophisticated mathematics, no model. Much of what you're doing at this end is to create appropriate mathematical models to avoid killing too many people or spending too much money. Put the two of them together, and they look like this. Now, in the general public, there are hundreds of places along that spectrum where you can claim the title engineer. Within the world of education, however, there are only 3 tracks. At that end of the spectrum, it's known as industrial ed, and industrial ed normally terminates with certificates, diplomas, associate degrees, and it largely terminates. It is not designed to take you on to a bachelor's degree of any form. Few of those courses may go with you if you go on to a 4-year education, but to a very large extent, you will be starting over. The other end of the spectrum is known as engineering education. It is calculus-based. In fact, you do not begin to earn credits towards the Bachelor of Science in Engineering until you are taking calculus-based courses. In the middle is engineering technologies. For most engineering technology programs, it's algebra trig-based, maybe calculus use, and if you plan on going on to a Bachelor of Science in Engineering, a Bachelor of Science in Engineering Technology, for example, at UNCC, E&IT, or Western Carolina, you will need to take additional calculus courses. Okay, so why is all this important? Well, you come on campus and you say, I want to be a welder. You get partway through the welding program and realize, whoops, I wanted to be an engineer. I'll trade in my welding credits on engineering credits. Is that going to fly? Well, no. You don't know the math, the science, the engineering principles, etc. Credit doesn't go that direction. Well, beat it. I'll go into the pre-engineering program. Get partway through that and realize, you know, I really did want to be a welder, and they make some pretty good wages. I'll trade in my engineering science credits on welding credits. Is that going to fly? Well, what can't you do? because you'd be great at the coffee pot. You talk about brittle fracture, heat affected zones, material properties, but you can't weld. That's a welding program. Credit doesn't go that direction either. Once you have selected one of these tracks and you get partway up and decide, whoops, I'm in the wrong track, and you jump to the track that's going to get you to your appropriate ultimate occupational goal, where do you think you land? Well, I just call it start over again, because that's essentially what you'll end up doing. So when this all boils down, the ultimate question that you have to answer before you even decide what field to go into is, where do you want to be on the occupational spectrum when you get done at Gaston College? And that's it.